In this video for section 1.6, we're going to talk about how to solve radical equations, which are equations that have a radical or a square root symbol in them. So the first one here is square root of x equals 9. So the question that we want to ask ourselves is what number, when we take the square root of it, will give us 9? Well, we know that that number is 81, because the square root of 81 equals 9. So what we're thinking about when we're thinking about what the answer is we're thinking about squaring the number on the right side of the equation. That gives us what x would be. So square root and square are opposite operations and they cancel each other out. So looking at number 2, we have square root of x plus 3 equals 12. So now what we're thinking about is what number, when I take the square root of it and then add 3 to that, will give me 12. So I know that before I add 3 to it, this has to equal 9, because 9 plus 3 is 12. So again, it's what number when I take the square root of it will give me 9. And so that's also going to be 81. So what we're doing as we think through that process is first we're subtracting the 3 from both sides. So that gives us the square root of x equals 9. Then, just like with number 1, we're squaring both sides to get x equals 81. Number 3 looks pretty similar, but it's actually very different. This time the plus 3 is under the square root symbol. So now what I'm thinking about is I'm thinking about what number, when I add 3 to it and then take the square root of that, will give me 12. So what I'm doing here is instead of subtracting the 3 first and then squaring, I'm actually going to square both sides first. Then I'm going to undo the plus 3 by subtracting 3 from both sides. So when I square both sides, I get x plus 3 equals 144. Now, when I subtract 3 from both sides, I get x equals 141. Looking at number 4, it's kind of a similar setup. Since we don't have anything outside of the square root sign, our first step is squaring both sides to get rid of that square root symbol. So when I do that, I get 2x minus 2 equals 16. Now I add 2 to both sides. So 2x equals 18. And divide both sides by 2, which gives me x equals 9. Now note that I can always check my answers here by plugging my value for x into my original equation. And that's always a good idea, particularly on a test, to make sure that you haven't made a mistake somewhere. So if I plug 9 in for x, I get 2 times 9 minus 2. The square root of all that equals 4. I know that 2 times 9 is 18. And I know 18 minus 2 is 16. And the square root of 16 is, in fact, 4. So it checks out. Let's look at number 5. Here we have minus 8 under the radical, and we have minus 2 outside of the radical. You might be tempted to combine these to get minus 10, but I can't do that. I can't combine things under the radical with things outside. So what I need to do is I need to get rid of the minus 2 first by adding 2 to both sides. Now, once I have the square root by itself, I can get rid of it by squaring both sides. That gives me 3x minus 8 equals 4. Add 8 to both sides. And finally, divide both sides by 3 to get my answer of x equals 4. The last problem looks pretty similar to number 5. We have a plus 5 here that we're going to get rid of by subtracting it from both sides. Now, when I get to this point, there's a problem because I have taking the square root of a number and getting a negative number. And that can't happen. When we take square roots of numbers, we always get positive numbers. So that means that once I get this negative on this side of the equation, I have to stop. Now this is a little bit tricky because you could continue squaring both sides and solving, etc. But that's not going to work. So I need to say that there is no solution. And I'm going to show you what this looks like in a homework problem right here. So in the homework, it's going to look like this. We have our equation here where when I subtract 9 from both sides, I'm going to get negative 8 equal to the square root. So what I'm going to select is B. The solution is the empty set. And that's going to be my answer for that question.